Hello everyone. In this session we will see how to generate a unit step signal, which is a second basic elementary signals which we study in signal processing or signals and system. So in the previous lecture we have seen how to generate a unit impulse signal using MATLAB code, MATLAB programming. So basically for the generation of unit step signal also we will use the same concept which we used in the unit impulse function, in the generation of the unit impulse function. So let us first see the theory behind this unit step signal. So unit step signal u of n is equal to 1 for n is greater than equal to 0 and is always equal to 0 for n less than 0, or you can say is equal to 0 otherwise. So the graphical representation, as you can see here, this is my time axis which is represented with n, and this is my amplitude axis. As you can see, at 0, 1, 2, 3, 4 and so on, we have an amplitude of length 1, and for minus 1, minus 2, minus 3, minus 4 up to infinity, minus infinity, we have an amplitude of 0, or you can say we don't have any amplitude there, we don't have any value there. So this is basically a unit step signal. So let's see how to write a program for unit step signal. So what we will do, we will directly copy the unit impulse function program and we will paste here. So as we discussed earlier, that CLC command is used to clear the command window. Clear all is used to clear the current variables which are being used in the program. Close all will close anything, any program which is being running behind the MATLAB. Now we have taken a length capital N equal to input length of the sequence is equal to that we will enter in the command window. The time n is equal to minus n to n. The initial value is minus n and the final value is capital N with the increment value of 1. This is how we can define the time. Now let us define the amplitude. Y is equal to square bracket start zeros 1 comma n. So it will generate a vector of length n having an amplitude equal to 0. Then the amplitude will be 1. Then for rest of the n values we will assign 0 by using the zeros command, zeros 1 comma n. We will close the bracket and we will use the semicolon. Now as we need to generate a discrete time signal, we will use the command time comma amplitude n comma y. Now label this particular signal, x label which is time, y label which is amplitude in y, and title generating unit step signal. Unit step signal, and the time we can write as n. So our program is ready. Let us save this program and run this program. So let us insert the length of the sequence, which is 10. Okay, so basically we need to change here once. So basically this once command will generate a stream of, or generate a row vector of length n having an amplitude equal to 1. So from 0 to, starting from 0 up to n, I'll be having a length of the sequence, I'll be having the amplitude equal to 1. So let us save once again and run the program. Length of the sequence is 10. And this is how we can generate a unit step signal. As you can see, this is my amplitude axis, this is my time axis. Time axis from minus n to n, which is minus 10 to 10. From 0 to 10, I have an amplitude of length 1. From minus 1 to minus 10, I have an amplitude of 0, or you can say I don't have any value. So this is how we can generate a unit step signal, which is a very important basic elementary signal in the signals and system. Thank you.